Okay, we're back. This second video on solving systems of equations. Before we get into the theory of matrices and row echelon form, what I wanted to do is I wanted to go over the algebraic method. Okay, so what we're doing is I'm picking a problem here. It's algebraic classwork. And that means we're not going to use matrices. It's still a system of equations. It's a 3 by 3, but we're going to use algebra. So we're going to do another example of that, and that should get you ready to be able to do, let's see, the take-home. All right, there is a take-home problem which has one algebraic and one problem by matrices. So this should get you ready. And what I'd like to do is give you an overview first. I'd like to go over the basic strategy. We begin with a 3 by 3 system. Okay. We get it down to a 2 by 2 by eliminating one of the variables. And that makes it easier, of course. And then we get that down to a 1 by 1 equation, one unknown, by eliminating another variable. So that's the plan. That's why we do what we do. And there are really a whole lot of different ways, approaches that we can take. So if you take a look at the system I have here, 3 equations, 3 unknowns, my plan is to eliminate the z's. Now, is that what I have to do? Absolutely not. I can eliminate the x's. I can work to eliminate the y's. There are going to be lots of different approaches. I'm telling you in this particular one, for no reason other than, I don't know, I'm going to try and eliminate the z's. So what I'm doing is I'm going to look at the first and third equation. Okay, I call them A, B, and C. So I'm looking at A and C, and I'm going to notice I get a 3z here and a 2z there. So what did I do here? 3b. Okay, I seem to have done this. Okay, so here's what I'm going to do. Instead, I'm going to work with the first two. I'm going to work with the A and B. Okay, I'm going to work with the A and B equations. I'm going to make this a -3 by multiplying it by 3, and I can eliminate the z's. Notice again, the x's have to be lined up, the y's have to be lined up, the z's have to be lined up, the constants on the outside have to be lined up, and the equal signs have to be lined up. So here's my equation A. Here's 3 times B. And now it's going to work out great. I can add these up and they will disappear. So I get 5x plus 5y equals -5. And then I just work with the A and the B. Now I'm going to work with the B and the C, and I'm going to try and eliminate the Z there. So clearly I got a -1 coefficient here, a +2 here. So I'm going to take equation B, multiply it by 2, add it to equation C. Okay, so that's the plan. And again, notice that the coefficients of the z are identical except for their signs. So I add them up, they will cancel. So I get 6x plus 7y is -11. So what I have now is I have equations D and E. So my new plan is to eliminate, I chose the y's, could have chosen the x's, I chose the y's in D and E. So 5 is not a factor of 7, 7 is not a multiple of 5. So what I'm going to do, I'm going to make them both 35s. Okay, so I'm going to take equation D and multiply it by 7, and equation E and multiply it by 5, and look at what I get. These are identical. So since they're identical, even with the same sign, subtraction is the way to go. You see, whereas here, there were identical coefficients, but with different signs, I added. Here I'm going to do a subtraction. So 35x minus 30x is 5x. These guys will cancel as we want. And 35 minus a -55 is actually +20. So I'm now down to one equation, one unknown. X is 4. I now backtrack and substitute in, and you can do that for yourselves. You get y is -5, z is -3, and this is our ordered triple, right? I could have put the set brackets around it, but go in alphabetical order, the x, the y, the z. So I got 4, -5, -3, and I did do a check. Okay, checks are important. We do checks. Okay, I don't know if we need to look at a second one at others, but sometimes strange things happen. So let me just spend a few moments and look at some of those. I'm going to skip number 2 because that works out very simply. Let's instead look at number 3, and these are all on Blackboard. Okay, so I'm looking at number 3, and I'm suspicious because I'm looking at the numbers 1, 4, -3, or -1, 4, -3, 2, -8, 6. Well, looks like these might be multiples, right? So I'm going to multiply this equation by 2, and I get this equation here, right? So 2 times by -2 rather. So 2 times -2 times this is 2x, -2 times this is -8y, -2 times this is 6z, and -2 times this, I really should have a -4 here. Whoops, my bad. Okay. However, if you compare that with the equation B, you'll find you have a contradiction there. Okay, so we're not going to get a solution. So that's how you would know if it works out like that. You would know. Okay, similarly, example number 4, some strange things happen as well. If I, let's say I add B and C, just because I want the z's to cancel out, I get x plus y equals 9, which is the same as equation A. So again, this isn't going to work out as well. We're going to have a single equation and 2 unknowns. We have a name for that. It's a line, yeah, so we do not get a unique solution. So let me get out of there. And at this point, what I'm going to do is I'm going to look at some notes. Okay, and the topic of these notes is matrices, the plural of matrix, and systems of linear equations. So we're going to have a new method for solving systems of linear equations. The first one was algebraic by addition and subtraction. We just did a couple of those problems. And what we could have done is we could have done them graphically as well, but it's hard to graph things in 3 dimensions. So this is another algebraic method because we're not drawing a picture. We're going to use something called matrices. And a matrix is a rectangular array of numbers. Okay? A system of equations can be modeled by an augmented, means increased matrix, which includes the coefficients of the variables and the constants to which they equal. So here's your typical 2 by 2. 2 equations, 2 unknowns. Now, if you take a look at this, just look at these. You got A1 and B1, A2 and B2. Those are the coefficients, and they appear in the exact order of equations, and it's augmented because we're also throwing in the constants C1 and C2. Now, so this is how we normally write this. We'd have numbers here for the A's, B's, and C's, and this is a matrix system. Notice that in the matrix system, it's really the same thing. All we're doing is we're not writing down the x's. I'd have an x here and an x here. I'm not writing down the y's, y here and a y there. And notice I have a vertical line segment here where I had the equal signs here. Now, the one danger, or the one thing you have to be careful of with a matrix-based system, is that the order is very important. That's why I've talked about this in the past. These need to be lined up properly. So I have a column for the x's, a column for the y's, a column for the constants on the outside, and a column for the equal signs. If you've got everything lined up like that, all you need to do is take the coefficients, and this becomes your augmented or increased matrix system because we're also including the C1 to C2. Okay, same thing happens for a typical 3 by 3. Okay, 3 rows and 3 columns. So basically, as long as everything is lined up, that's very important. You got the x's, you got the y's, you got the z's, the equals are lined up as well, and the constants are lined up. This is how we go from a regular algebraic system to a matrix system. And again, notice the alignment of the variables, very important. Okay, a system of equations in matrix form is solved by using the following allowable row operations. And when they say row operations here, what they're really talking about is manipulating the equations, because each equation is in its own row. So, first off, any 2 rows can be interchanged. Well, that makes sense. If I write the first equation first and the second equation second, and I do the opposite, I put the second equation first and the first equation second, obviously I haven't changed anything. Okay? A row may be multiplied by a non-zero constant. Well, that's what we were doing before. We take equation A, we multiply it by 2. Same thing. And a non-zero constant multiple of any row or equation, when you see the word row in this context, means equation, can be added to any other equation. And that's what we've been doing. We took, like, I think the last example, negative 2a, right? Negative 2 times equation A, and we added it to equation B, and that's what this is talking about. Okay, now let's talk about the goal. Now we're going to do a lot of examples of this, and there are examples on Blackboard, and we'll go over this. In fact, there's a whole set of classwork examples, which we'll do in the next video, and there's a whole set of homework examples which with the solutions, which we'll also look at in the next video. None of those I'm collecting. I will show you what I'm collecting shortly. Okay, goal. The goal here is to transform the original matrix into row echelon form. Echelon is like an array of soldiers. Row echelon form or row reduced echelon form. I'll explain the difference. It's kind of easy. Here's row echelon form. Notice you got 1 in the upper left-hand corner. You got numbers on the main diagonal. You got zeros here. And who knows what here. These are going to be any old numbers. Okay? That's the idea. Reduced row echelon form simply means that you made all of these guys ones. So in other words, if this is the equation 4y plus something z equals something, I just divide everything by 4, it would make that a 1. All right, that's all you do. So this is called row echelon form. This is row reduced echelon form. This is what we're shooting for. I'll show you why. Okay, so we want ones along the main diagonal. All right, so if the variables are, well, let's not say that now. Ones along the main diagonal, zeros here, any old numbers there. Okay, so that's the idea. Let's look at an example. Whoops. Here we go. Now, this is the example that we did in the last class. Okay, notice the 12, the negative 9, the negative 4. We're going to do the same thing, but now it's going to be from a matrix point of view. So we're going to be going through probably the same processes as we did here. Okay, so here we go. This we did in the last video. And now we're going to use matrix. Now look at the instructions. Solve using row reduction and matrices and check. Well, I'm not going to do a check because it's the same problem. It's the same answer I did over here with a check. So I'm not going to check it. So, okay. So look at the instructions. The instructions here, solve the 3 by 3 system algebraically. That means by addition and subtraction. That's the old way. The way that you learned in Algebra 2 when we practiced last time in the last video. And now we're going to take the new approach. We're going to work, and we'll work with this for a while. Solve using row reduction and matrices and check. Okay, so let's talk about the basic plan. First of all, this becomes this in matrix form. Notice 3, negative 2, 1, and 12, 3, negative 2, 1, and 12. The coefficients now, 1, 3, negative 2, negative 9, 1, 3, negative 2, negative 9, and so forth. So we transform the system of equations with x, y's, and z's into matrix form. And again, this is only going to work in a satisfactory manner if everything is properly lined up, including the equal signs. Okay, this is sort of like synthetic division. I don't know if you learned that in pre-calc 1, but in synthetic division, you don't write down the place values, you just write down the actual numbers. So it's the same thing. Okay, so here's what we want to do. Row echelon form means we have a 1. Let's see if I can get that back up. Yeah. Row echelon form means we have a 1 in the upper left-hand corner. So, notice there's a 1 here. So why make yourself crazy? All we're going to do is swap the second row, which is the second equation, with the first row, and that you get here. And notice I wrote down what I did. I interchanged rows 1 and 2. Now, the upper left-hand corner is a 1. That's what I want. So, if you go back here, I want to make everything under that zeros, right? So whether it's in row echelon form or row reduced echelon form, I want zeros under that. So I'm going to show you how we do that. It's pretty easy, really. Well, so I'm keeping this row fixed because I've got the 1 there. And I'm going to say to myself, how do I make this element a 0? Well, if I multiply this guy by -3, and I add it to that, that'll make it 0, because -3 times 1 is -3, -3 plus 0, plus 3 is 0. So that's what I'm going to do. I'm going to multiply the top equation by -3 and add it to the second equation. So -3 times 1 is -3, add it to here, 0. -3 times 3 is -9, add it to -2, -11. -3 times -2 is 6, add it to 1 is 7. -3 times -9 is 27. 27 and 12 is 39. So notice what I so far have accomplished. I now have a 0 in this. I'm moving toward row echelon form. I now want this element to be a 0. Well, I do the same thing. In my mind, I say, what do I have to do to this 1? That when I add it to here, I get a 0. Well, I have to multiply it by -2. So I'm now going to multiply, in my mind, I'm not actually writing this down, I'm multiplying this in my mind by -2. I'm going to add it to row 3. And that's what it says here. Add -2 times row 1 to row 3. Okay, so here we go. -2, well, let me do it, let me do it here. -2 times this is -2, add it to 2 is 0. -2 times 3 is -6, -6 and -4, -10. -2 times -2 is +4, add it to -3 is 1, and -2 times -9 is +18, add to -4 is 14. So now I'm almost there. I've got a 1 upper left-hand corner, and beneath it I have zeros. So if you go back and you look at it, I'm gradually creeping toward row echelon form. I've got a 1 here and I've got zeros below it. Okay, so let's do the next part. Now, the next step is I want to make a 1 here. And what I would rather do is, well, let's see, if I'm working with -10, I just divide that by -10. I don't want to divide by -11. That's a little crazy. So what I'm going to do, I'm going to swap rows 2 and 3. And I'm going to divide this by -10 is a 1. All right, well, let me just do that. I'm going to swap the second and third rows. And I'm going to divide this by -10. So that becomes a 1. This becomes -1/10, and this becomes -1.4. So that's my new second row. And notice I accomplished my goal. I wanted a 1 there. Here's what I did. Okay, I swapped rows 2 and 3, and I divided the new row 2 by -10. Cool. Now, I've got my goal here, row echelon forms, on 1s on the main diagonal. So I've got a 1 here, I've got a 1 here, but I also want zeros below. So I want to use the 1 here to kill the negative 11. So what I'm going to do is I'm going to take this row, multiply it by 11, add it to the third row. Now if I multiply 0 by 11, it's still 0. It's not going to affect that, which is what I want. See, it's why I'm working with the ones. Multiply this by 11, add it to that, get a 0, okay? Multiply this by 11, I get negative 1.1, add it to 7 is 5.9. You have to do some calculator stuff here. Multiply this by 11, all right, and add it to 39, you get 23.6. You got to whip out your calculator for that. So let's see, that'll be, I think 15.4. Yeah, this will be 15.4. Negative, add it to 39, that's how I get to 23.6. Okay, so now let's look what I got. I've got, this is almost done here, okay? My goal is row echelon form. So I want 1, that's good, 1, and this should be a 1 on the main diagonal. And I want zeros below. So the way I make this a 1, I divide by 5.9. So I divide everything here in row 3 by 5.9. 0 divided by 5.9 is still 0. Same thing here, 5.9 divided by 5.9 is 1. And 23.6 divided by 5.9, I believe, is 4. And that brings us to here. Okay, now this is in row echelon form, which is very cool. Now the question is, so what? What does that do for me? Well, at this point, you think to yourself, I want to go back to the equations with the x's and y's, because each of these rows represents an equation. So I'm going to go back to equations. This row, right, is x plus 3y minus 2z equals negative 9. So that's the top equation. Second equation, well, 0 times x is 0, so I got y minus 0.1z equals negative 1.4. And the beauty of this is, look at the last row, z equals 4. So now I'm pretty much back in the world where I want to be. I've got z equals 4, and I start by moving up and substituting just the way I did before. So once you get to this row echelon form, you're going to get z equals some number. All right, then you just sub back in and you're done. All right, so we sub back in. So if z is 4, 0.1 times 4 is 0.4, so y minus 0.4 equals negative 1.4. I add 0.4 to both sides, I get y is negative 1. I'm now going to substitute z is 4 and y is negative 1 into my top equation, and I get x is 2. So x, y, z, 2, negative 1, 4, parentheses, because the point, that would be my solution. Okay, so this is the first example that we did of solving a system by matrices. So what I want to do is, I do believe I have something labeled homework here. Let's see if I can find it. System of equations, matrices, homework, and solutions. So let's look at the homework first. Now this is on Blackboard. And the cool thing is that I'm giving you a couple of problems to do. These are the answers. And I also have solutions fully worked out on Blackboard. Okay, so what I want you to do before you attempt to do the problem set take home is I want you to go through this, try them. They're worked out step by step, and I put little notes on how I went from step to step. And you're going to find that once I get it into row reduced echelon form for these problems, I translate it back into x, y's, and z's, and I do my backwards substitution, and I get my answer. So what I want you to do is I want you to give these a try. And I'm going to come up with another video. It'll be class 22, I guess, part 3, and I'll walk through a couple of these. Okay, but you're really not going to get anything out of these unless you try them. All right, so it's not that easy, but I'm going to make sure that the numbers are reasonable. I'm not going to give you crazy, insane problems, and unless I warn you in advance, the problems are going to work out to integer solutions. So that's the idea. Okay, so go back over these. They're on Blackboard with the solutions, and then we will have another video where I'll go over these in the near future. Okay, so be well and isolate and do a lot of math. Okay, bye bye.